Hello students, in the last class we had seen what is the first principle or the definition of the derivatives. So according to that, f dash x, that is the derivative of given function fx, is limit as h tends to 0 of f of x plus h minus fx upon h. So let us see some of the problems on this, or rather some derivations. So first of all, suppose fx is equal to x square. In that case, what will be f of x plus h? F of x plus h means I am replacing x by x plus h. So it will be x plus h the whole square. And using the expansion, binomial expansion for x plus h the whole square, this will be x square plus 2xh plus h square. So by the first principles, the derivative of fx, that is f dash x, I can write it as limit as h tends to 0 f of x plus h minus fx divided by h. So that is limit as h tends to 0. Now f of x plus h, that is x square plus 2xh plus h square minus fx, that is x square divided by h. So x square will cancel with x square. Now from 2xh and h square, I can take h common. So that will be limit as h tends to 0. I am taking here h common. So that will be 2x plus h upon h. So from 2xh, h will come common, so 2x will remain, and from h square, h I am taking common, so h will remain. So now h and h will get cancelled, and in the limiting case, what will happen is this will become 2x plus 0 because h is tending to 0. This is the limiting case. So that is 2x. And hence derivative of x square is 2x, which I can also write it as d by dx. D by dx is the symbol for derivative. So d by dx of x square is 2x. Now let us take one more example here. Suppose I want to find out the derivative of x cube. So fx is equal to x cube. So f of x plus h, that is x plus h the whole cube. You have already studied about the binomial expansion. So by Pascal's triangle, the coefficient in a plus b the whole cube is 1, 3, 3, 1. That means you will get the terms x cube plus 3. First coefficient is 1, then 3. Reduce x power by 1. So x square. Write h here. Next coefficient is again 3. Again reduce x square power by x power by 1. So x square. Next will be x and increase h power by 1. That will be h square. In every term we will reduce x power by 1. So x cube, then x square, then x, and go on increasing h power by 1. So in the last term the coefficient is 1. So it will be just h cube. That is the expansion of x plus h the whole cube. So by first principles, f dash x will be limit as h tends to 0, f of x plus h minus fx upon h. So put these functions here. Limit as h tends to 0, f of x plus h is x cube plus 3 x square h plus 3 x h square plus h cube minus fx is x cube divided by h. So again here, as you can see, x cube is getting cancelled. Now from the remaining terms, take h common, so you will get limit as h tends to 0. So I am taking h common, that will be 3x square. Now from 3x h square, h I am taking common, so 3x h will remain, and from h cube I am taking h common, so h square will remain upon h. So from 3x square h I am taking h common, then 3x h square, h is coming common, and again from h cube h will come common. So here 3x square, then from second term it will be 3xh will be remaining inside, and from the last term h square will be remaining inside. So again h is getting cancelled, and in the limiting case, see 3x square is not going to get affected by the limit, but 3xh and h square both will become 0. They will both tend to 0. So finally the limit is 3x square. That means I can say the derivative of x cube is 3x square. So now here one thing you can see when it is derivative of x square, it is 2x, that is 2x to power 1. Then we have seen that derivative of x cube, again it is 3x square. So in both these cases, what can you see common? When you take the derivative, the power comes down and the power of x reduces by 1. So when it is x square, 2 has come down and power of x has reduced by 1. So it has become 1. Similarly, x cube, 3 has come down and power of x has reduced by 1. So it has become 2. So in general, I can say derivative of x to power n is n times x to power n minus 1. So n has come down and x power has reduced by 1. Just as an example, suppose you want to find out derivative of square root of x. See this formula I can also apply to the powers which are not whole numbers. So root x, that means I can write it as x to power half. So using this formula, it will be half times, half has come down, x power will reduce by 1. So that will be half minus 1. So that will be half x times half minus 1, that is negative half, which can be also written as 1 upon 2 root x. So keep this in mind when you take the derivative of a function which is in the form x to power n. N comes down and power of x reduces by 1. So just you can practice this on the following functions. So write the derivatives of this d by dx of x to power 6, then d by dx of 1 upon x square. See, using the laws of indices, 1 upon x square, I can write it as x to power negative 2 and then apply the formula. D by dx of 1 upon root x. Now 1 upon root x, write it as x to power negative half and apply the formula. So just try these problems at home. See you in the next class. Bye students. Any doubts, please make them clear in the next class.